Hi everyone. So I wanted to make a video to give you an example of if we have to go remote, what kind of things we'll expect. I'll do some synchronous teaching where we'll be in class together via Zoom. And I also, throughout the semester, regardless, I like to post videos. If there's a certain concept or problem that I see people were all missing on the OWOW, I'll often just make a video of it, of the solution, so that you can see how it's done and you can refer back to it. And these are found under, obviously, the video tab in under Blackboard. So this is the note packet that we received on Tuesday. And so I want to skip ahead because I just want this to be a short video. I want to skip ahead to make a little video on some sequencing. So I am on the front of the 5th page. And we're going to look at some sequences, either arithmetic or geometric. So I'll give you a minute to find that page. And I'm going to start in the middle of it. And I'm starting right here where it says, young children explore many similar sequences and that can then determine the pattern and continue the sequence. So what I want you to do is I want you to look at sequence 1, 2, 3, and 4 and take a minute, you can stop the video if you need to, and see if you recognize the pattern for each of those. There's a very defined pattern, and I want you to see if you can identify it right away. So you might want to make like a little note here on how each of these sequences are formed. And then specifically, we're going to start looking at the first sequence. So stare at it. And if you can figure out what the next term in that sequence is, then you have recognized the pattern. So I'm hoping right now you're all saying to yourself, oh, Kathleen just added 3 each time to generate those terms in that sequence. So let's break this apart and see if we can figure out what's called a formula to generate that pattern. All right, so the first term of the sequence is a 2. Okay? So the second term, now I'm going to write this a little unusually. I'm going to write the 5, which is the second term, but to get to that 5, we took the first term and we added 1, 3. I'm hoping you'll all agree with that. The third term of the sequence is 8. So we took the previous term, which was 5, right? And then we added 3 to it. So that got us the 8. So when we're on the third term in the sequence, we took the original starting value and then we added 2 3s. So the fourth term is 11. So we took the previous term, which was 8. I'm going to write 8 like this. And then we added 1, 3. So if I'm the fourth term, I have my starting value, and then I added 3 3s. So the fifth term is 14. So we took the previous term, which was 11, and we added 1 3 to it. So the sixth term, I'm hoping you guys are going to say, well, it would just be 14 plus 3, which is 17. Or it would be the sixth term, so it would be a 2 plus 5 of these 3s. Because did you notice the number of 3s that we have is 1 less than the position we're in? So if we're in the 4th position, we have 3 of these 3s. If we're in the 3rd position, we have 2 of these 3s. And if you calculate that out, you'd have to, PEMDAS says multiply first, so 15, 16, 17. So the book gives you this formula, but now I'm hoping that you're going to see how it's generated. So for the nth term, you're going to start off with a 2, and then you're going to add a whole bunch of 3's. And the number of 3's you're going to add is 1 less than n. So n minus 1 number of 3's. All right, so let's see if we can figure out the 20th term. So the 20th term in this sequence, you're going to have a 2 plus 19 is 1 less, so 19 of these 3's. So let's look at this calculator. Ready? So we'll have 2 plus 19 of these 3's. So the nth term, or the 20th term, is 59. And you can do this for like the 300th term or the 1000th term because you've recognized the pattern. Now the formula for this kind of sequence deals with the starting value, and it deals with the number that you're adding to generate the terms in that sequence. Now when you add a value to generate a sequence, it's what's called an arithmetic sequence. And here's the formula. It's A plus. Now n minus 1 shouldn't shock you, right? And then the formula the book uses a D. So A is the starting value. Okay. N is the position. First position, second position, position of the value in the sequence. Okay. And D is the number you're adding each time to generate the sequence. So the value being added to generate the sequence. So this problem up here, upstairs, the formula, like this is the general formula, but to fill in the missing pieces for that sequence, it would be 2 plus n minus 1 times 3. You need to fill in the starting value and the number that you're being generated. And then n is going to be presented in the problem. They'll say, what's the 20th term of the sequence? So n would be 20. What's the 500th term of the sequence? So n would be 500. And this is kind of a cool concept because we can figure out the 500th term in the sequence as long as we recognize the pattern so we can generate the formula. All right, so check out upstairs. Do you recognize another one as arithmetic, where you're just adding a value to generate the terms in a sequence? You're adding one value to generate the terms. Do you see that it's sequence number 3? So the first term is 3. The second term is 5. The third term is 7. The fourth term is 9. The fifth term is 11. So if you can see that the next term, the 6th term, would be 13, you've recognized the pattern. You've seen that you're adding 2 each time to generate the terms in that sequence. Does everyone agree? That is what is called arithmetic. So to figure out the 20th term or the 500th term, you need to figure out a formula for the nth term. Okay, so here's the general formula, and then we're going to fill in the missing pieces. So A is the starting value. So A would be 3. Plus, remember I said the n minus 1 stays in the problem. And D is the value you're adding each time. So we're adding a 2 each time. So let's go ahead and figure out the 20th term. And then we'll figure out the 100th term. So if we had to keep adding 2 each time, it would be 3 plus 20 minus 1. So we need to add 19 of these 2's, right? You can put it in your calculator like that if you don't want to do the 19, right? So 41 would be the 20th term. If I said what's the 100th term of the sequence, not any hard. It would be 3 plus the 100th term minus 1 times 2, because you'd add 99 2's to that 3. 201 would be the 100th term. So if I kept adding 2 plus 2 plus 2 plus 2 100 times, that's what I would get. I'm telling you, this is much easier to do it this way than to try to add a 2 100 times on your calculator. All right? So that is what is called arithmetic. And you'll have this kind of problem on your next Oh Wow. But we have other terms in the sequence we got to look at. We got to look at these terms in sequence 2 and 4. And they're definitely not arithmetic, right? We're not adding a constant to get to this. We're not adding the same value each time. So I'm going to flip. I'm going to write down the order that I see for sequence 2 on the next page. Okay? So let's see. So we had what did we start off with? A 3. Yep. So the first term was a 3. The second term was a 6. The third term was 12. The fourth term was 24. And the fifth term was 48. Now, if you could tell me right now what the sixth term is, what would you say? Did you say, oh, well, Kathleen, it looks like you just doubled this each time. Or another word for doubling is to multiply by 2. So the next term in that sequence is a 96. But I want to know the 20th term. So on my calculator, I'd have to go times 2, times 2, times 2, 20 times. But there's an easier way, because if you recognize a pattern, we can get to a shortcut to go from the first value to whatever value you're looking for, as long as you see that there's a pattern. So let's go ahead and generate the formula like we did before. All right, so to get to the 6, we took 3, the starting value, and we multiplied it by 1, 2. To get to the 12, we took our 6, and then we multiplied that by 1, 2. To get to 24, we took that 6, and we multiplied it by 2. I mean, you can check that out on your calculator. It gives you 24. So you always want to take like the previous number. So there it is. And then multiply it by 2. So what are you noticing about the number of 2's again? So if you're in the 4th position, you've got 3 2's. If you're in the 5th position, you're multiplying by 4 2's. If you're in the 6th position, you're going to take that starting value and multiply 5 2's. It's always 1 less than the position you're in. Does that make sense? So if you're in the 20th position, it's going to be a big number. It gets big fast. You're going to take that 3 and multiply it by 19 2's. So this is where it comes out nice, just to start using exponential notation, right? So we don't have to keep writing all those 2's out. So it'd be 2 to the 5th. It just is a little bit cleaner looking, right? 2 to the 4th. So I can do that on my calculator. Let's do this one. So 3 times 2. To raise something to a power, I use that little hat, some people call the little caret key. It gets big fast, so don't self-doubt. These numbers get big quick. Look at that. So that would be the 20th term, starting out with 3 and multiplying by 2 each time. So the formula, which they give in the book, but I just wanted you to see how the formula was generated, right? Like if you see that there's a pattern, you should be able to find a formula. So here's the formula. A, which we know what A is, that's the starting value. R, they call R the number you're multiplying to generate the sequence to the n minus 1. So A is your starting value, like always. and R is the value being multiplied to generate the sequence. The number you multiply by to generate the sequence. There you have it. Okay, so let's look at the last sequence, and then you'll see that these are on your, not this week so well, but next week so well. You'll have some of these. Recognizing whether it's arithmetic or geometric, being able to identify the next term of the sequence, and then being able to identify a number pretty far out in the sequence, like the 100th term or the 300th term. So the last term, or the last sequence for this, started off with a 2, then 4, then 8, 16. I'm writing this one down. Do you see it? I'm writing this one down, the fourth one. 16, 32. Okay, so I'm hoping that you could see this. Get a little color so you can see it. If I said what's the 6th term, tell that's a different color. 6th term, you'd say, oh, Kathleen, you're just doubling it each time. In this case, you're multiplying by 2. And it can be being multiplied by any number. It doesn't have to always be multiplied by 2. I just happened to pick a problem where they were both by 2, but it can be by 3 or by 5 or by 10. You'll notice that they're different values. So the formula then is A times R to the n minus 1. So let's fill it in. It'll be 2. That's our starting value. And then we're multiplying by 2 each time to the n minus 1. So if I said, what's the 20th term? It would be, so the 20th term would be 2 times 2 to the 20 minus 1. So it would be 2 times, and you can even do the 20 minus 1 right upstairs while you have that into your calculator. Okay? Big number. 1, 0, 4, 8, 5, 7, 6. So it's over 1 million. It gets pretty quick, big very quickly. So I'll start class off just practicing this a little bit, and then we will jump right into where we left off on Tuesday when we come back and finish. We'll probably finish off this packet, but I just wanted to give you time to get into Blackboard, to know how the video lectures are going to work. Oftentimes, I will just post a video, especially if I've noticed people are struggling with something. You'll see a video pop up like after I grade the WOWs. I'll say, all right, everyone seemed to have missed question number 3. So please go, I did an example. It's posted in the video lectures under Blackboard. All right, so make sure you bring in some questions for me. I will see you on Tuesday, and I hope you had a good weekend. Right? We will see you then.